Hello, in this video I'd like to show you how to use the capture component. Once installed, you'll find it on the RADii tab, and in the first category here you can see you have two components. One is the capture component itself, and then there's a small tool that converts point cloud to colored meshes, and I'll show you that at the end of the video. But first of all, let's bring in the capture component. And you can see it being generated here in Grasshopper, and also in the viewport of Rhino you can see some information. You can see a representation of the camera in space. By default it's at 0.0.0. You can also see the name of the camera, you can see the camera plane, you can see the near clipping plane, and you can see the far clipping plane. And then the component itself, you can define a custom camera plane for the orientation of the camera in space. You can define a clipping point box for extracting very precise information out of the point cloud. And then there are the control of the clip near and the clipping plane far. And then there are some information that you use to control the different filtering that I'll go into. Then there's a small toggle that turns on the camera, and then there's a small toggle that starts the capture. If the camera is not attached to your computer when you drag in the component, you'll get a small warning telling you to connect the camera. And once you have, you can right-click the component and then press connect to camera, and they should connect. And you'll get the proper information both on the component and in Rhino. But on the component itself, you have some information that you can choose. First of all, you can select your camera. In my case, I've only have one installed, which is the D435. You can see some different information, but the main thing is that it runs on USB 3.2 in this case. If it's on USB 2, you will lose a lot of the performance that the camera can do, so make sure that it's attached to a USB 3. Also, this means that you can have multiple RealSense cameras attached to the same computer and capture from them individually. Just drag down another component and select another camera and then run it at the same time, and they will capture their information into the same scene. Then there are the settings of the two sensors. There's a depth sensor and a color sensor, and then below is a series of filtering that you can do to that information. But first of all, let's just look at the depth sensor here. It's set for 30 FPS, and it has a resolution of 848 × 480. And then the color sensor is now running at 6 FPS at a high resolution. And I'll get back to that later, but let's just go with the default setting and turn the camera on. So you turn it on, and if you look at your camera, you can actually see that it's running by the small red dots that you can see in the sensor. And then you can start the capture by doing this. And now it's capturing a non-colored point cloud at 30 FPS. And you can see here it has a near clipping plane and a far clipping plane. So the first thing we could do is adjusting these. So the far clipping plane, of course, clips the extent of the point cloud, and the near clips the near, of course. So I can just go a little bit further, closer to the camera, and then you can actually see my hand on the computer while I'm recording this. And it's running at 60 FPS, and you can see how it's coming in here. So the first type of filtering you can do to the point cloud is the decimation filtering, and that's the one that you have here. And once the camera on, you cannot select another camera, and you cannot change the color and depth sensor. You have to turn it off to change those. But the first thing is the decimation filtering, and this simply you define how many points you want out of the point cloud, and it's by default 2 by 2, but you can go all the way down to 8 by 8, and 1 by 1 you'll get it in the full resolution that the point clouds are coming in. So that's the first one. So let's keep it at the default here. And then the second one is something called a spatial filtering, and this tries to align points to a surface. So if you have a surface like the wall that I have over here, I have my computer here and I'm pointing towards a wall, and there's a small architectural model over here that we're looking at. There's also a bottle over here. But you can see that the wall is a bit uneven because of the tolerances of the camera. So if I wanted to have this much more smooth, I can turn on spatial filtering, and it will try and smooth out points that are close to each other. And you can choose a different magnitude for doing this. Right now it's at 2, but I can set it to 5, and you get a quite close to even surface. This also has an impact on all the features on this small model here, because you can see if I turn it off, I get all the features back in the model. So it has a cost. So turning on spatial filtering, you get nice even surfaces, but you also get a reduced sense of depth, and you can see it here on my hand when I turn it off. you can see that I get much more depth in my hand, and the features of my hand are much more precise. But turning it on flattens my hand, but also creates, you can see it's almost geometrical, these shapes that is created. So it's off by default, but you can help create surfaces by keeping it on. The next one is temporal filtering, and this samples points over time and finds an average of over time of where these points are positioned in space. So here you can see they are a little bit excited, the points, they're moving about a little bit, but if I turn it off, you can see how the points are actually coming in much more with much more noise, because that's how it captures its point. But it's also in real time. If I turn it on, you can see there's a little bit of ghosting going on with my hand. You can see it has this ghosting type because it samples between frames. But if I turn it off, I get the raw data, and you can see it's actually at 30 FPS as I move my hand. So, and you can see that the points are much more excited, but I can turn them, the temporal filtering on here, and I can also define how many frames it looks at these points from over here. And furthermore, I can adjust them over here all the way to a point where they are actually not moving at all. And this introduces stable points, but you can also see it introduces a lot of ghosting across the frames. And the minute I turn it up again, they start to move and they fall into place. So there's a trade-off also here of this ghosting, but also you get these much more stable points in space if you turn it off. The next filtering is something called a hole fill filtering, and this just tries to fill in gaps that are in the point cloud. And it will try to do the best it can. Here it finds out that maybe there's also a surface down here. It can get some strange results, but it can fill some holes. And there's different methods of this. There's nearest around, and then there's left from right, or left to right, and then there are some other settings. And they are also off by default. And now let's get closer to my hand here. Let's just bring in the far clipping plane so we focus on my hand, which is here. And the last thing that you can add to all this is coloring. And this comes from the color sensor. So let's turn on color points. And you can see here now the effect of having two sensors running at different speeds. You see the color is coming in at a lag because it's running at 6 FPS. And the color, maybe I turn off temporal filtering, you can see it a bit better. You can see it's simply lagging behind because it's coming in at only 6 FPS. So it makes sense to have them running at the same speed, but they don't need to. Also, you can see some points are colored differently, and that's because those colors lie outside the color sensor, and therefore they are just colored orange. And you can also simply decide to crop to those. That means there are only colored points in the world here. But let's fix the FPS issue here. So I turn off my camera here. And then I go in and make sure, let's set it to 60 FPS just for see how it can run. You can even see that the depth sensor can actually run at 300 FPS. The color sensor cannot run as fast, but let's set them at the same here. So now they're both at 6 FPS. Let's turn off color just to have a really fast rendering of this. And now it's running at 60 FPS. And if I turn on the color as well, it's also running at 60 FPS. This has quite some limitations. If you have a lot of points, the coloring can reduce the frames per second. But if you have few points like this, they catch up the coloring. But if you want real fast points, you simply turn off color points, and then you have very fast point counts. So let's stretch it out here. And I also turned off the temporal, so let's get that back in there, like so. So now I'm going to show you how to use the clipping box. So we simply just define a box with which we want to clip. So let's make a box and put it right around where we want it, like this. So there's our box, and we drag it into somewhere where we want to clip, maybe just my hand. And then we record that in the grasshopper here, like so. And let's not preview that, and then just fill it into the clipping box. And now you can see it simply clips to that box. And I can move my hand in and out of that box, and it captures it in space here and then out the other end here. Let's have the color on too. So now it's sort of just within this box, and this can just be adjusted on the fly to get whatever information you want out of the point cloud. And this brings us to also the point cloud to mesh component that I have here. If you bring it in here, you can simply define a plane that the mesh is projected against. This makes sense that it's the same as the camera plane. This is why the camera plane is brought through the component out here, so you can use it to create the mesh. And then you simply just feed in the point cloud. And now I have a colored mesh here that creates the mesh as it's happening here. And you can see I move in and out of the clipping plane. And if I do a little bit here while also stopping it here, like so, I can go in and bake this mesh like that, and then move it up here, and then I have a copy of that baked mesh with color information. Put it to wireframe again and delete it here. So, and of course this will, if you have a very large point cloud, this can be quite heavy to do, but you can also run it just on a stationary point cloud like this. Let's get this out here. This component is, once the capturing is running, it's blocking. That means if you run it at 6 FPS, the component will run at 6 FPS. And that means that you can have some stutter while running in Grasshopper. So the best is always to run at a quite a fast sensor rate like this, for example, 60 FPS. And then let's say you actually wanted to maybe just extract points every half second. Because the component is now running at 60 FPS, I can simply just put in a trigger that's set at 500 FPS, turn off the auto capture here, and then just add this. And now you can see it's capturing it at just every half second. You know, it does its capturing. I can see my hand moving here. But internally, it's running at 60 FPS. I just only choose to get the information at the frame or at the pace of the trigger here. If I turn it off here and run it here, it will run at the actual FPS that is set by the camera. Let's turn it off here. You can also decide to replace this with a button, like so, and then just run it whenever you want. You can simply just hold it down, and it will do the capturing while you press. So there are different ways of triggering the capturing. Let's get it in here. And the last thing I didn't show you is the ability to change the camera plane. So let's just put in an XY plane here and feed it into the camera plane here. And then it's oriented towards that. So it just defines the camera plane. And if you know this camera plane from something, let's say the camera is attached to a robot, you could maybe query that plane from that information, and then the scanning of that robot would be placed correctly in space. But without anything, it's just projected into space like this. This plugin goes well with RADii viewers as well, so you can publish real-time point clouds directly into the viewers as well. That's it for this video. You can play around with these different settings to figure out what they do. But otherwise, that's it for me. I hope you enjoy this plugin and that you find it useful.